What we want to do in this last section is to finish up talking about the boot process and what that entails and what that involves. It's something that you don't normally find in an introduction to computing course, but we do need to at least give you some understanding of what it means and what are we talking about when we talk about the boot process. And to begin with, let me just identify that the boot process is the first part of what happens when you turn on the machine, when you actually push the on button on your laptop or with your tower case and you reach down, and press the button and turn it on. This starts a process known as the boot process. And what happens in particular is there is some startup mechanisms that begin inside at the motherboard level that have been hardwired at the factory to begin with. What in essence is going on is some very, very small startup procedures are taking place. It's called POST, P-O-S-T, power on, and ST is for the startup procedures. And you'll hear these series of beeps, okay? And these beeps are supposed to indicate that everything's taking place in the right order. Now, some of this has to do with simply things like the system clock and checking that, and also turning on things that have to do with setting up the display mechanism, and also going and getting the operating system, because it has to be loaded each time that you turn the machine on. And it's hard to believe, but it actually does have to happen every time. So by grasping the boot process, you have an understanding of the sequence of events that occurs when the computer simply starts up, step by step. If this procedure fails, then you will not be able to access and use any of the applications or any of the data that you've saved on your machine. So it's a very important part of how things happen. And if it becomes corrupted, if the boot sector gets infected in some way, say with a boot sector, something where there's not some files, there's some missing files, or they become corrupted in some way, then the boot procedure will not take place appropriately, and you need to have some idea of how to handle that. Now, what is the purpose of the boot process? It involves a lot of flashing lights. As you can see, there are these noises you hear as the fan turns on and other types of gizmos inside begin to whirl around like the hard disk itself. And then the computer performs these, like the beeps that you hear, this self-diagnostic test on the machine, and that's called POST. And each one of those letters stand for something, by the way. It's power on self-test. That's what it stands for. And so it's going through these sets of things to do that you don't necessarily know about or see, but it's definitely something going on. Sometimes there's bad news because it's able to identify or find out that there's something not working properly too, and it can stop right there. This is when you might have to get a technician involved, because if the boot process isn't working, there's very little that you can do personally to fix that, and you might have to involve someone who knows more about the diagnosis and problems that you're going to be encountering here in the boot process. The boot process also serves a very critical additional purpose that I've already mentioned, and that's to load the operating system, the large operating system, from the hard disk into memory so that you can use the rest of the machine. Now, what does this mean precisely? Again, we need to understand that this is why we have to have a lot of memory. This is why RAM is important. This is why the more RAM you have, the faster and more efficient your machine operates, because it has to have all that memory to accommodate a lot of these processes and procedures that take place to start the machine and to put everything together so that you can use it. The first thing that tends to happen is what they call the start boot program. The start boot program. The microprocessor begins to execute what is called the bootstrap program that is stored in ROM. Now that's not random access memory, that's read-only memory. Those are the processes and procedures that were loaded and hardwired at the factory. These are things that you can't change and I can't change. They're part of how to get everything out of Central Station and onto the railroad track and moving on down the tracks with the computer. Then there is the power on self-test. That's when you see all the flashing lights and the diagnostic test and you hear all the beeps, a series of beeps. That's when that takes place. Then you have what's called the identification of the peripheral devices. The operating system, once it has loaded completely, it begins to identify any peripheral device that is connected to the computer and checks their settings to make sure all of that is in proper order. This is like your printer and any external hard drives that are currently attached, even this webcam, which is a peripheral device, or any other thing that might be attached, say some kind of disk reader or CD ROM reader or something like that that you have attached to your machine. It checks all of those types of things. Now, once this is done, they check the configuration of the entire machine. This is what the operating system does. And it's looking for any customization issues that have to do with specific devices. And sometimes when things don't work properly, you can go back and uh, click on something known as last known good configuration. Now that's what it's talking about here, is the configuration has to be assessed by the operating system to make sure that your machine is all set up and ready to go now. Because at this point, we're beginning to get ready to serve up the logon screen and get it ready to where you can log in and you can actually see the desktop appear and see everything gets turned on that's supposed to run while you're using the machine. So this is important, as you can imagine, when it comes to using your machine. Now what happens though, what happens if you press a button and the machine doesn't actually turn on? What if you have a point at which the machine just stalls, or there's a black screen, or maybe a blue screen, or maybe something like that? What do? You want to make sure that the power is correct to begin with too. You want to make sure that your batteries are not, losing power or getting to where there's no power, and you're not able to use the machine because of a lack of power. Your batteries need to be fully charged, or you need to make sure that it's plugged in all the way. So there can be physical issues that really are at stake here as well, because you're just not getting enough power, or maybe there's something to do with heat or temperature. The computer should be plugged into a surge strip, and you make sure that it is turned on and functioning properly too. So another thing you can do is, if you have a delay in things and you only have a black screen, is to make sure that the power inside, you can hear something, okay, like say a fan moving or some other device. Do you hear any sounds inside the box is what I'm trying to get at. These are indications that things are okay. If they're not running, if the fans aren't running inside, then you've got a problem there, even though it's plugged in at the outlet. The post notifies you of a hardware problem by displaying an error message that can help you to pinpoint the source of a problem. It emits a series of beeps to get your attention to. You just have to know what the series of beeps mean. But a lot of times you can get just an error message that is displayed on the screen. Now, unfortunately, many computers display these error messages as numeric codes, and you don't have necessarily a technician's resources to interpret these codes with. For example, one of them I have in the lecture notes is 1790 disk 0 error, for example. Now you can type these into Google, type them into some kind of internet resource, and you can find what these codes mean, and you can find out more about how to handle them and how to understand them. Specifically, though, the beep code provides you with a way to signal a problem. Okay, it's telling you there is a problem, even if the screen is not functioning. The 2 short beeps might mean a problem with the keyboard, for example. 3 long beeps might mean a problem with the screen display. Beep codes differ from one computer to the next, and depending on the ROM bootstrap program, they can be real detailed and have very specific meanings. The printed online reference manual that you can perhaps find, you can download and make a copy of it, or you can just try to find internet resources that will help you to diagnose your problem and get a little closer to what to do about it. Now, many times you'll find that you can have information displayed on the screen that is very technical in nature. You can have, for example, who made the machine, copyright information, what the kind of specific processor is inside the machine, the memory test, the plug and play information, as well as other kinds of information pertaining to starting up the machine. Now, this means a lot more to a technician than it does to, say, you and me. But your familiarity with it will help you should you have some problems with just getting everything started and your machine not working. I have students all the time that will generally every quarter will say something that their machine's not working, I can't start it up anymore, and I have a black screen, or I don't have anything but some error message and I don't understand what the error message is. And so I include a boot process module section in the lecture in order to address this concern, so that students who do have these problems can have some information that's readily available to help them to figure out what to do with their machine and to correct any problems that they're having. And don't feel alone, because it happens to a lot of people. So the boot process, you can get a lot of information on your particular machine and its process by going to the internet and doing some research and finding out in particular what happens with your machine when it starts up. Thank you again for your attention, and thank you for all the ways in which you have participated in this class, and hope to talk to you soon.